class. Okay. Today we are going to discuss about OSPF. In the previous class we discussed about EIGRP protocol. In the last class we discussed about EIGRP. So in EIGRP, what are the concepts that we have discussed? Feasible distance, successor, feasible successor, right?
Yes.
Can you explain what are we talking? Feasible successor, right? Successor.
Yes.
And also, what else we have discussed? We also discussed about
administrative distance.
Yes, yeah. It's a distance vector protocol, right? EIGRP.
Yeah. And it's only
right?
Cisco proprietary one.
No. Yes, exactly. That's correct. EIGRP Cisco proprietary. That's very correct. Very good. And what else you have discussed about EIGRP? It works on the...
It uses different metrics.
Yeah, we already discussed that. What else?
And
we also discussed how election process.
After
right.
180 seconds, it will drop the request.
No, 180 seconds is what? It's a hold down timer.
Invalid. The
hold down
request
timer.
becomes invalid.
Yeah, it will update its EIGRP topology, right?
Yes.
Right?
Yes.
Whereas in OSPF, we will call it as database. We will come sequentially first. So, how feasible successor, how the feasible successor is based on AD plus
AD and FD.
AD.
Right?
AD and reported distance.
FD.
Yes. Administrative distance plus
Feasible
what
distance.
is FD distance?
Feasible distance.
Or
Feasible distance.
reported distance. Right?
Yeah.
So we are talking about discuss spectrum protocol when it's updating its topology, right?
Yes.
Whenever we do show IP, whenever we do show IP EIGRP neighbor, we are discussing about feasible successors. Okay?
Yes.
That's it. Let's go. But what else we have discussed in EIGRP?
The maximum half limit we discussed.
Very good. Very good. What is the maximum half limit?
224.
224.
Okay. We also discussed Kavya in last class. Which layer EIGRP or OSPF works? Okay. We have also discussed that. You see here, show IP, EIGRP topology, we have what? Feasible successor and successor, right? And also, additionally, we have who are going to be the next successor. For example, if I go to this router, enable show IP EIGRP neighbor, show IP EIGRP topology. At one point of time, we were able to see more than one successor in the router. Which router is that? This guy? Or the person? Okay. So whatever it is, so we were able to modify the bandwidth and influence the router to select a different path than what it is intended to write. We also did that, right?
Yeah,
by modifying.
I think we shut down one.
The serial links and also modifying bandwidth of the link. So, because bandwidth is one of the EIGRP metrics. Okay? We discussed about this, right? EIGRP metric.
Yes.
And also we redistributed the static routes to EIGRP table. You remember that?
Yeah.
Redistribute static.
Yes.
Yes.
Yeah.
Redistribute static. Okay. Redistribute static in the network about the EIGRP. Now we are going to the next topic, which is OSPF. Okay. Okay. So I guess you dropped the meeting. You're back. Okay. It's saying you dropped the meeting. Okay. It's back.
I'm back, Harsha.
Okay. Now we are going to discuss about OSPF. Okay. So before we start about the OSPF, we will discuss the same we discussed about EIGRP here. Okay. The OSPF actually you can apply in a much bigger network, more than maximum hop limit is 224 or 255. I don't remember. Fixed that count. Okay.
No, it's 224 for user.
224. Okay. Yeah. It's a number, right? So better remember. So OSPF you can apply across much bigger network that can span over bigger areas, right? So before starting OSPF, what is the difference between OSPF and EIGRP? OSPF is not.
This is not
Yes.
Cisco proprietary.
And it is also not a distance vector protocol. What it is, it's a link state protocol. Okay? What do you mean by link state? That we will discuss now. See, distance vector protocols, they send updates at regular scheduled intervals, regardless of whether there has actually been a change in network topology or not. Right? They keep sending their advertisements, right? For example, in a stable network, you just imagine that network is very stable. This is waste of network resources, right? See, once the initial exchange of LSS takes place, for example, between two OSPF neighbors, in the OSPF neighbor there is advantage. You see, for example, if there is an LSS, link state advertisement, we are talking about link state advertisements now. What is an LSA? I will explain in short time. In OSPF, this is the basic mechanism. The LSS advertisements or exchange of LSA will take place between two OSPF neighbors. Okay? Only when there is a change in network topology. That means if LSA advertisement took place now, it will not update its next advertisement until there is a network change. And also, LSAs are updated every 30 minutes. So router will also advertise all its LSAs, okay? So it will also advertise LSS between OSPF configured routers for every 30 minutes. This way you can save a lot of bandwidth, okay? You understand? There is also a very good advantage of OSPF. OSPF does not use the distance vector, right? Instead of that, what it is using, it is exchanging the OSPF table between the neighboring routers. For example, I have already configured OSPF here, okay? Enable. So IP OSPF database. Remember here I am not using the word topology. So it is using what IDs here? Link IDs. You see that, right? In EIGRP we will do so IP OSGRP, EIGRP topology, right? Here you are doing what? You are doing link advertisement, so IP OSPF database. Each network, it is been adjoined by link ID. So IP OSPF neighbor. Here it is giving also neighbor ID and also the time interval and also the address. Okay? Because we just activated the router, right? Let me do. It is building up. You see the time is building up. So it is also giving the neighbor ID address. Okay? Neighbor ID and also IP address. Okay? So what is the difference between OSPF neighbor ID and ID address? We will discuss that one also, okay? We will also discuss that thing also. What is a neighbor ID, neighbor address, and what is the priority, how the priorities can be set, and what is the state. See, link state advertisements. So we have a link ID, we have a state also. So it is advertising what? Link ID and state. So that is how the OSPF works. Now you can ask me, what is a link state advertisement? It is nothing but whether that link is up or down. So whenever a new network is added to the OSPF, it will also advertise its link state advertisement. Other than that, how much time it will wait before it manages to send its link state advertisements? How many minutes? 30 minutes. Very good.
30 seconds.
minutes.
Seconds,
No.
right? Yeah.
No, 30 minutes. That is the whole point. We don't want to keep, see, for example, look at this. If all these OSPF routers are sending their advertisements, there are so many advertisements coming from all these routers, right? It will be very, very busy. For example, I'm sending OSPF packet to here, and in the real time, I want the packet type to be of, how do I change the type I want to type? Edit filters, okay? I only want to send OSPF packets. You know what I'm saying? So now capture. Now see here how the OSPF packets are going. Okay? Let them keep going. So from here to here I'm sending OSPF packets. You will keep seeing how the router will keep on updating it, sending the packets, and see how they recognize after matching with its table. See, in links, every 30 seconds, they will see whether the link is up or not. But the topology will not be updated every 180 seconds. Remember, when hold time expired, the topology has been updated, right? In EIGRP. Did you understand? In EIGRP, we brought down the physical link, and then we wait for how many minutes, how many seconds? 180 seconds.
180
And then its topology updated. In the link state, if you bring a net link down, it will immediately get updated. And here also, it will also send hello and hold 10 packets. I'll show you. Show IP EIGRP summary. So IP OSPF database. So IP OSPF summary. It's one command actually. So IP OSPF interface actually. Yeah. You see here. Hello packet. Hello during 0.5 seconds. See? Hello during 0.5 seconds. Hello during 9 seconds. Hello during again 9 seconds. So here the hello and dead timers are 10 and 40 seconds. Just in case interfaces are updating. You know what I'm saying? There's a big difference in EIGRP and OSPF how they update their database. Okay? You got, is there any confusion? Is there any confusion? Let me know. See, the 30 minutes, they will update all their database, okay? And the rest of the protocol, like the link state advertisements and all those like checking hello and dead timers, it is all same like EIGRP. The network you are looking at here is point-to-point network. How come it is a point-to-point network? Can someone tell me why this is a point-to-point network? I'm using serial links here. Remember, I gave homework difference between point-to-point network, regular T1 link, serial link. If you have read there, point-to-point network usually comprises of serial link, and it will be like router to router. And I have already configured OSPF on them, okay? You see, here the hello letters are updated every 10 seconds and dead timers are 40 seconds. But if it is a multi-access network, it will be 30 seconds and 120, okay? I will show you how to configure multi-access segment, okay? I am going to do that today, and I am going to configure in front of you and show you how the OSPF election process works. In EIGRP, feasible successor and successor participate in election, right? Using distance. Here, Here, they have a mechanism called electing designated router and backup designated router, okay? Designated router, backup designated router, DR other. I'm not going to show slides. It will be very confusing if I show slides, okay? And also it's waste of our time. So go through the slides and let me know if any topic that you are unable to. Designated router and backup designated router. And the third one. I cannot show designated router, backup designated router, designated other election process in point-to-point network. I will tell you why. See here, how many networks we have here. Okay? See here, how many networks we have here. This guy is one network, right? This guy is one network, right? This guy is one network, and this is one network. The serial links are point-to-point networks. So, how come if selection, which one will be designated router and backup designated router here in this network? It can be any. It can be this router or this router. If you observe closely, there is no election here. Enable show IP EI OSPF neighbor. It is only saying that the state is full. It is only saying that the state is full. It is not saying in the flash, it is saying dash. It will mention either designated router, the neighbor ID, or backup designated router. It will say that, but we are not saying here because in this network, even if you consider this as designated backup designated router, if one link goes down, there is no election, right? This network is down. You are understanding the difference?
Yes.
I'm going to configure multiple access. I know you are confused. This is very difficult to understand. Let me put like 3 routers here, okay? This will save time. I'm not going to select serial links. I'm going to select what? I'm going to select fast Ethernet ports. Why? Because this is not point-to-point network. See, once you enter OSPF, we will discuss a lot about network topologies, like multi-access point-to-point. There are other topologies also, okay? What are the topologies? Like multi-point broadcast, multi-point non-broadcast, non-broadcast MA. These are all network topologies. These are in WAN. This we will discuss in CCNP class. We don't have time to discuss all that, but I am taking time to explain the difference between point-to-point topology and multi-access topology. Now see here, everyone. Okay, observe closely here. Now router to switch, which cable should I use? Did I use right cable? Everyone, did I use right cable?
Yes.
Okay. Now see. This is all one big network, right? let's name this network as Control G. I'm able to Control G. Okay. Let's name this network as 192.168.1.0/24. Okay. Now, Kishore, tell me the difference between this network here. Sorry, let me clean this here. Okay. I just want to put there. I want to be more diagrammatic. Okay. Come on. Okay, that looks much better. See, Kishore, this is all one big network. Okay. Now, can you tell me the difference between this entire network? Every router has one interface in that network, right? 192.168.1.0, right? Kishore, can you answer? Where are you? Yeah. Hello, Kishore. Kavya.
Yes.
Here, this is each network. There are only two routers. So that is point to point.
Right.
If you
Point to point,
point is down, network is down. Here, that is not the case. In this network, the square block, there are how many routers?
3.
I'm going to configure.
3 routers.
Okay, I'm going to configure this as 192.168.1.1. Can I?
30.
I'll do 1.2. Okay.
Yes.
This interface I'll configure as 192.168.1.4. Okay. And this interface I'll configure as 1 second, guys. I got full call. Okay. Okay. Never mind. 192.168.1.5. Okay. So let us assume. So this is multi-access network. So how many routers are able to establish to this network? More than 3. Now, will there be election process between 3? Forget about how the election process works for now. Okay? Just assume that this is one big network. Can you tell me, will there be an election process between these 3 routers? Yes or no? Will there be an election process between these 3 routers? Yes, right?
Yes.
You can speak out.
Yes.
Why? Because more than
You can work from down.
one router is accessing the area, right? More than one router is accessing the area. This is what we call multi-access. And this is fine. So now we will configure OSPF along with me, and you can also see how the election process takes place. And we will also influence this router interfaces, so that, and also the router ID, so that we can make sure we are able to observe all different kind of election processes by influencing the router ID, by influencing the IP OSPF priority. And there is one more important point, okay? The EIGRP, we have discussed all these things about EIGRP, right? EIGRP, how it functions? It functions on the link state advertisements and on the interfaces, right? If this interface has, more bandwidth, or if you modify this, you can modify the EIGRP, right? And then in OSPF, actual election process appears, actual election process is conducted on the router rather than on their interfaces. You understand? This is like a sensitive topic. To understand that, you should understand how it happens on the router ID. You should know what is a loopback interface or what is a router ID. Router ID is nothing but if you're configuring a router with a management ID other than interfaces ID, it is called router ID. It can also be a loopback ID. Remember how I configured loopback ID during the EIGRP class on the ISP router? Remember, Kavya?
Yes.
I also configured static route to that loopback and redistributed to the EIGRP table. Similar way here also we can configure a static ID, static address, and redistribute it to the OSPF. There is a different command for OSPF, okay? No, for now, what we have to do, we have to configure OSPF, right?
Mm-hmm.
So how will you do that? There are various ways to do that, okay? Let me configure this. We don't want to run out of time. Interface SA00, okay? Show IP interface, please, okay? So we will configure which interface here? SA0x0. Conf T interface SA0x0 no stat. What is the IP address? What is the IP address we are using?
192.
Okay, 192.168.1.2. Subnet mask
255.255.255.0.
Single shot, right? That's gone green. Okay? And there is also another IP address here, another interface. So fast internet configure T interface fast internet 0x0. Let's name that network address as IP address 25.25.25.1 then 255.255.255.252. Why I'm choosing only 250 subnet? Because there are only 2 ports on this network, right? I don't want to waste
Yeah.
the IP addresses. Okay? SA0x0. Why this thing is not on? Show IP interface brief. Okay. SA0x1. Wait a second. Oh.
It says 01, right? We configured 00, right? Interface SA00 again.
Yeah. That's what I mean. So no problem. What I'm going to do, I'll cut this one. I'm going to take this. Also, I'm going to cut that one. I'm going to change the cabling, okay? That's what you do. I can also, F01 what is I configured, right? Now, run interface F0x1. No IP address. Interesting. Why no IP address? Configure it, right? Configure T interface SA0x1, right?
Yeah.
Yeah. So IP address 192.168.1.2 255.255.255.0 no shut.
0.
Okay. So IP interface please. This is up now, okay?
Yeah.
Okay. Something happened before. Why this simulator is still running? Let's close this. Okay. Now configure this guy. Okay. Now how do you configure? No. Enable. So IP interface please. Conf T interface SA0x0, right? Let's want to make sure this is SA0x0. Okay. What is the interface address? IP 192.168.1.4 25.0. Shut. Okay, interface. Let's say 1/0. I will also configure this. What is the address we took for this guy?
25.25.25.1.
Okay, very good. Then thanks for remembering that. What is that? Interface SA 0/1. Okay. Yeah. 0/1 IP address. Right after. 25, right? 26.26.0.
1.
Okay.
We configured it as 1. Yeah.
Yeah, we cannot configure .0, right? Because it's a network packet. So IP interface to this, right? Okay, looks good, right?
Yeah.
So I want to give control to you guys so that you will also configure simultaneously. So here, SA00. What is SA00 address? Configure T, IP interface SA0/0, IP address 192.168.1.5. So shut. Configure T, interface SA0/1, IP address. What will address is 27.27. Okay, Kavya, you with us, right? 52. Okay.
Yes.
Remember, you should.
Yeah.
10. Okay. So IP brief. This is administrator down because we didn't do show that. No set. Interface SA0/1. No shut. So IP interface brief. See. You understood, right? Are we all in the same line?
Yes.
You understood how these are all different networks?
Yes.
Yeah.
For some reason, this guy is not blowing up. Doesn't like the router or not. Stop off now. Very good. Save. Now what we have to configure? Now we have 3 routers here, right? Okay?
Yes.
DR, BDR. Oh boy. 1 second, guys. Something. Yes, start run out. I'm trying to start my PC. Let me see if it's there. So connected in my hardware. Connected. don't know how long it will take to power on. Give me 1 second. I'm struggling to... You are able to see my screen, no, right?
No.
Okay. I'm restarting PC. That can take 5 minute break.
Okay.
back. So here we are discussing about BDR elections, right? Before discussing about BDR election, we discussed about what? We went into this point-to-point topology router, and what I've discussed here, show IP, OSPF, neighbors, and we saw that the state is full, right? The state is full here. What do you mean by state full? See, there are 8 OSPF adjacency states. When I mean adjacency, LSA, link state advertisements adjacency, OSPF adjacency. What does this mean? Initially it will be down, right, and it will attempt to connect. When it is connecting, init state means it is initializing OSPF establishment. Once it is trying to establishment, two-way handshake will happen. And then extort exchange packets will be exchanged. Once they both are exchanged, the establishment will load it, and then finally the stage will convert to full. So in order OSPF to keep an adjacency, to establish an adjacency, these are the 8 stages that it needs to go through. Okay? Okay? Okay, Kavya? So, we have understood how the adjacency is formed, but we want to know how the election process takes place. Just like successor and seriable successor. Here we cannot take that election process because I explained here. In OSPF, it does not consider the the interface metrics, the cost metrics, or the distance metrics, or the number of hops doesn't count. What counts? OSPF happens inside the router, not at the interface level or the count level. So this is what it matters. Adjacency matters. So we configure an area here, okay? I will show you how I configure OSPF area and all. And let us call this as area 0, okay? So within the area 0, you are propagating OSPF advertisements, LS advertisements, right? So what matters here? Which one is designated router, backup designated router matters. And when the election process take place, the router ID is 1. What is the router ID? I already explained. Loopback ID or management ID of the router. Second one is OSPF priority. So these both will influence the OSPF election. Understood, right? Now let us configure the OSPF, okay? The recorder is on, right? Okay. Enable. Enable OCDP neighbor. Okay, we have both neighbors, okay? So IP interface, this we have both. So configure T, router, OSPF. What is the process ID we will choose? Give me any process ID, any number. Let us say 5, router OSPF 5, okay? Now we have to add network, right? What's the first network? 25.25.25.0, 0.0.0.3. What is the area? See, this is the difference between AIGRP and OSPF. In addition to network command, we will have area command. Area, what we have considered it as 0, right? Please say yes or no. Network, the next one is 192.168.1.0 0.0.0.265, right? 255. Area 0.
0.
Okay?
Yeah.
And is there anything else that I need to configure?
No.
Distribute static we can configure, but we don't have any static routes configured on this router, right? Do we have no IP route? We don't have any static routes, right? So IP OSPF database. We have 1.2. Okay. We have two networks configured here. Okay. So right. Advertisement router and the link ID is. Now, can you tell me why the link ID is .1.2 but not 25.25.1? Can you tell me why? Can you tell me, Kavya? Because this is router ID, and what is the biggest of IP addresses of both?
It's 25.
192. That's why router ID is selected as 192.1. Let us go. Let us do the math. Okay. Does this have one more fast Ethernet port? All right. So I think it doesn't have any fast Ethernet port configured. Okay. Let me first support this here. Okay. Okay. Let me connect the fast Ethernet port. Cannot have one more connection. It is very bad. Okay. What I can do is I can take one more router here. So this is for understanding the concept of router ID. Okay, I'm blocking. I'm muting you. Okay, it's noisy. I'm going to connect. Oh boy. I need to show you how to install router. I need a hard connection. Okay. For example, what is the router ID here? Show IP, OSPF, okay. What is router ID here? Kavya Kishore. Kavya Kishore, we are talking about the router ID concept.
It's 1.13, right? The
Right.
above router ID.
Why? How it took 1.30 as router ID?
Because it is big. I mean, it is the larger address among both the addresses.
Okay. I'm going back here. Okay. Let us configure management items. Okay. I interface management we have here. Unfortunately, we don't have management. I'm configuring loopback 0. Okay, Kavya. IP address 221.221.221.221.4. Okay. Let us assume so IP OSPF database. It will not work. I will show you. It will be still 1.2. Why? Because we didn't add loopback address into the OSPF network. Let me show again. Show run interface loopback 0. Loopback 0. I added the address, right? I did not add address. Oh boy. Configure P interface loopback. That's why I added it. Didn't okay. IP address 21.21.0. No, one. I'm giving the network. That's why it didn't. Okay. Understood why it didn't set bad marks? Because you are giving a network address. Understood, right? So, IP OSPF database. Configure T router OSPF. Yeah. Outside is what? 5. Network 199.199.23.0.0.0. Area show IP OSPF extent. Why it is still in the world? Can you tell me why it did not take the loopback as it process ID yet? We'll come back and see. Okay? During the election process, let's see if it takes the highest interface ID as router ID or not. For now, it took this ID. Okay? It should ideally take this ID because OSPF probably will wait for some time. We will see how long it will wait before it's taking the router, updating its router ID. So let's go here. Okay? I'm going to configure OSPF on this one. Okay? Configure T router OSPF. What is the area ID? Process ID 5, right? Network. What's the network? One 192.168.1.0, right? You can speak out. 55 area 0, right? Network. What is the next network address? Sure. 27.27.27, right? Network 27.27.0.0.0.3 area 0, right?
0.
Show IP OSPF neighbors. You see that? Now election process is happening here.
Yes.
Choose as 1.2 as designated router. Wait, why didn't it choose 1.5 as designated router? Can you tell me why? Because 1.5 is bigger than 1.2, right? Let's go here. See, the adjacency is how they are sharing adjacency, right? And then state is loading to full. What it is loading to full? What is the state number, adjacency state number 7 loading? It went from loading to full. This all will happen when the link goes on. We will also cover this, how the state will appear on the interface, okay, OSPF interface. For now, let us do this, okay. Let us go here and you show IP OSPF label. Oh, it's selected as a designated router. For which area? For which area? For area 0, right? Show IP OSPF database. So IP OSPF topology, not topology. OSPF interface actually, sorry. Interface area 0, right? So let's go here. Let's go here and configure this guy. Conf T router into show. It's a command if you are on config mode and want to do show command. You have to use do. Otherwise it will not work. Okay, so router OSPF. What is the OSPF? What is the? You can give any ID, but area should be same. Okay. Network. Okay. Network. What's the network? 192.168.1.0.0.0. Area 0. Network 26.26.0. 0.0.0. Dot 3. See, as we finish the command, it says infinite because we didn't mention area. It already went to full loading to full OSP adjacency form. See, this converging time is very, very fast. In ESGRP, it is not this fast, right? QIP, OSPF. You did understand, right? It selected 1.2 as designated router and 1.5 as backup designated router, right? So IP OSPF neighbor. Ideally 1.5 should be designated router, right? Because it has a bigger router ID. But we configured this guy first. So it took the priority, okay? Now show IP OSPF neighbors. What is here? It's selected as designated router 1.2. What is backup designated router here? 1.5, right? Go here. So for the entire area, 1.5 is backup designated router. What is 1.4 then? What is 1.4 then? Designated router other, right? Why? Ideally, 1.5 should be designated router, 1.4 should be backup designated router, 1.2 should be backup DR other, right? See, there are 3 states. DR, designated, DDR. DR other. Right? These are the three different routers within the area. You see how we are talking about election process by calling the router ID here instead of feasible successor or successor, going to the interface and checking the feasible successor distance. Here we are checking with the router. That's why OSPF process happens inside the router ID. The reason why, see, ideally .5 should be designated router. .4 should be backup designated router. .2 should be DR other, right? How come .2 become DR and .5 become BDR and .4 become DR other? Doesn't make sense. The reason because we have configured this guy first and then this guy next. So what I'm going to do, see here, okay? I brought down that link, okay? Now let's go here. Now I brought the designated router down, right? What will happen here? How long it will wait? 30, 18, 15, 14, 13, 12, 11. What is the, this is, see, for the point-to-point network, 10 and 40. For the other, hello timers is 30 seconds, right? Yes, Kavya? Now what happened after 30 seconds? That timer expired. Neighbor is down. Kavya and Kishore, you should speak out. You see election process, how it's happening here.
Yes.
Very clear picture, right? Now let's do try IP OSPF neighbor. Now you have to tell me before I type this command how the election will finish. Which one will become DR now? Which one will become BDR? .2 is down now. Okay.
Yeah, if dot 2 is down, then dot 5 will become the DR, designated router.
Okay. And dot 4 will become BDR, right? Let's see.
Yes.
Do you agree, Kavya? Earlier, dot 2 was designated router, dot 4 was DR other, and dot 5 was BDR. Everything was up and down. Now let us see. Now dot 4 become backup designated router, right? Now, what is the designated router?
5.
Dot 5 become designated router. Now I am going to bring the link up, okay? Okay, going to say that. Now, can you tell me what will be the status now?
Still should be the same.
The status
Right.
will be the same.
No, see, wait for how many seconds? See,
30.
30. 10
and 30. It's going down, right? Dead timers, how many seconds? 120 seconds. Dead time. Hello timer is 10 and 30. Dead time is 120 and 40. For networks like this, it's 40. For networks like this, it's 120. Because why you need longer time in the multi-access?
Because in one area there are multiple routers.
Yeah, so many routers. So now look at here. 2 become DR other, dot 5 become DR. Does it calculate our math? Does it justify our math now? Initially,
Yes.
now did you understand the concept of router ID?
Yes.
What is router ID? EIGRP, the process is different. It's basing on the link metric. But OSPF, the process is happening on router. What is the advantage of this? Very fast conversion. And also, there is you can create multiple areas. You understand? We can create multiple areas and distribute it. So when I say multiple areas, right?
One doubt.
Yes. Yeah, go ahead.
Like in EIGRP, in EIGRP, the dual algorithm will choose the best successor for the transmitting the packets. But whereas in OSPF, according to what you said, so now the best path will be chosen across the designated router. Is it?
The best path will be selected by Zikastras algorithm. Okay?
Oh, okay. Okay.
See, here the best path is selected once you select a designated router with ISID. The reason behind is, so we have a designated router, right? Every router will share their updates with that designated router. Okay?
Okay.
So the routes will propagate from here to the next designated router, or between area border router, or area backup designated router. There are so many routers, okay? The concept here, this is how it works. I will show you.
So the designated routers will decide the best path.
No. See, the best path will be, there is no best path here. The best path, there is only shortest path here. What is the shortest path to reach area 0? What is the shortest path to reach area 0? This router 7. Sorry, what is the designated route?
Router 11.
Router 11.
Yeah, router 10.
Instead of your propagating your all routing tables to the entire area, you will just distribute to the router 10. And the router 10 will share all its updates with next routers. This is how the shortest path first. How you are selecting the shortest path first? This area will go on then with another WAN area. This will go on another with another WAN area. Right?
Yes.
Basing on the priority of the router, it will choose the processor. On how the priority of the router is going to be set, we can define it, right? You can also give OSPF priority. You can also modify the priority of the area, which router to be designated router.
So Harsha, in this protocol, right? So basically, if we prefer to go in one route, we can configure with that highest IP address in that direction, and we should be
Right. See, in the link state data bus, right, what will the router will, it will keep the count of LSAs it receives from other routers. Okay? You understand?
Harsha, I'm losing your voice.
Sorry, you are not able to hear me?
No, I'm losing your voice in between.
Okay.
Yeah.
See, in OSPF, selecting the shortest path route, right? Selecting the shortest path to reach these routes, it doesn't matter. Once you configure the entire network in one area, you already have the routes to each router. You understand, Kavya, the difference between EIGRP and OSPF? You are getting there. You are asking me how it will select the shortest path first. We already have link state advertisements to all. For example, if a packet comes to this router, where will it send it? Where will it send it to the destination? Where will it send the packet next? Let's see. Let's send the packet from here to here. Okay. Okay. Switch 2 doesn't have functional ports. We need to put a PC here. Understand that concept. Okay. Let's just put a PC there. Can I put a PC there? Yeah. So your question, you're asking me, right, how the shortest path will be selected in OSPF, right? Let us work it out, how it works. Okay? So what is the IP address here?
25.25.25.2.
Right? 255.25. What's the gateway? 25.25. Okay. Let us see how the packets propagate.
26.
See, the OSPF, once it reaches the gateway, the backup designated router or designated router, right, it will use Jigsaw algorithm to find the shortest path, okay? You understood, right? How that algorithms work, we will see it in function, okay? Okay.
You didn't give the gateway.
Okay. You cannot send K20 which router backup designated router. 20 switch. It should go ideally here, shortest path, right? But where it is going, it send both packets. It send packets to multicast packets. You see that? Both presented tick mark. Where it is going next?
It should go to 5, right? Because we brought 2 down and brought it up, right? It should go to 5 only.
It's going which management you said?
It should go to 5 only. So,
Which 5? This 5?
yeah. Yeah.
So actually here we are only studying about it failed, okay? Some reason it cannot find it. It's sent to routed the 10. And it's sent here also. It basically they are sending multicast packets. Yeah, it's sending multicast, not broadcast. And it's reaching, it will put tick. Okay, it's also talking. Right. It will send multicast, not broadcast. Okay? You understood, right? Ping 25.25.25.1. It's not pinging. The routing is not working because we did not. Okay. Something wrong here. Are we able to ping the 25 dot from here? You see how the OSPF packet is being sent? Source of the destination address. Right? See the Ethernet packet. This is not OSPF packet, right? OSPF packet will have link state advertisement, LSS and everything. There's something missing in it. This is now how it sends, okay? Now let us stop this. It failed. We need to see the routing working or not, okay? Something happened here. We are unable to ping this guy. Are we able to ping the gateway first? Ping 26.26.26.1, okay? Are you able to ping it? We are not able to ping the gateway. Why? For some reason, switch is not allowing. Show IP OSPF network. We don't have show one. You see, we don't have the subnet 26.26.0. This network participating in what you call OSPF. You see that? You see that, Kavya? That is why. There is no way this router knows about this network, right? Enable show IP route. Okay, it knows about the subnet. It knows. Ping 26.26.26.1. Why it's not pinging? Interesting, right?
Yeah.
That route is being advertised here, but we are not able to ping. 27 is also advertised here. 25 is directly connected. Why it's not able to ping? Let's see. You can troubleshoot that. This is what we are here. Control Shift X6. So run. Did we add subnet mask wrong? 252.
That's correct.
Why it's not pinging? Let's ping the other network addresses. Ping
27.
Sorry?
No.
You can ping other addresses because they're all directly connected. So I'm unable to ping one that it's not configured, right? Ping 1.2. We're not able to ping any.
No, ping 1.5. You're 1.
See, 1.2 is directly connected. Nothing, we are able to ping nothing. Show IP interface brief, okay? Ping 192.168.1.2. It's directly connected network. It's not pinging. What's happening here? Did we block ping or what? We are unable to ping any, right? Why? Here, see, this is also I configured. Show run, okay? So we have these addresses. Show IP route. I have all the addresses connected via this, right? For example, this PC is, what is this? 20.1. Let me do from here to here. So let's see how it's progress. It's working, see? Now let's see the packets. I want to see the OSPF packet, okay? They are sending Cisco discovery protocols. They are not sending OSPF packets yet. I only want OSPF packet. I want OSPF, okay? Now I will get to see OSPF packets here. You see what packet is selling? OSPF? Hello, right?
Yes.
This is OSPF hello. What is area ID? 0. What is router ID? This one. What is jet interval? 40. Why? This point to point. There is no backup designated and designated router here because it's point to point setup. It's OSPF hello packet, right? And remember here, where it is OSPF working here? Which layer it is working? Link layer. Data link
layer, yeah.
And the only IP address, see, OSPF hello packets are being sent at layer 3, but basic functionality it works at link layer. You see, we are looking at packet level administration here. Let us do the same here, okay? Why it's not working? Why they're not pinging? That's a very big puzzle now. For me, it's a big puzzle. We did some, maybe we missed something important, okay? From the packet, please. Okay, so did we play autoplay? No, we didn't. Okay. Now look at OSPF packets here. OSPF hello is sending. Hello interval is sending. This is not good. The designated router is 27.27.1. You see here? Here it is confusing with designated router interface. You see how it is configuring designated interface 27.27.0? This is not it should advertise. You see what's happening here, Kavya, Kishore? The OSPF packets are being attached with transit name.
The IP address should be 1.5, right?
Where? Yeah, that's right. That's correct. I want to see the packets so that I can grab one packet and see what's happening there. I'm waiting for the packets to go here. It's saying successful here. PC to PC. No, that was different, right? router 11 to 7. This is the reason it's not working. What happened, man? Okay, let's see that. Show, enable, show IP OSPF neighbor, okay? OSPF neighbor. Now designate router. Let's ping its neighbor, 192.168.1.2. It's not pinging. Okay, let's see why. It's interesting, right? We should troubleshoot this. We have 10 more minutes. Show IP interface, please. Show run interface fast. Show CDP neighbor, okay? Show CDP neighbor detail. So I cannot able to ping my own address 192.168.1.4. Is there any command that I'm missing? OSPF packets are working fine, right? They are elections are working fine. Default information object. That is for default route, okay? Log adjacency changes. That is not going to make any difference. Okay? That's not going to make any difference. We should be able to ping. It should be able to ping. I'm just confused why it is not working. So IPO database. Area is 0. Area is what it matters. Process router ID, that's what it is. It knows link ID also. You see, it's giving link ID, giving advertisement ID. Why it is not? We have everything. Right? We have dead timers also. Everything. Why it's not working? I mean, you don't need routing to ping the PC to the gateway, right?
Yeah.
You don't need a routing for here. It's pinging here. It came, the reply came. It's taking time. What I will do is, I will save this, okay? I will save. I will open. Okay? Now let's do it. So let's get them active, okay? Now, custom interface ping 25.25.25.1. Okay, it's not. Maybe show IP is OSPF neighbor. We have 26 subnet. We have all the subnets now, right? Ping 25.25.25.1. Yes. We are able to ping now, right? 25.2. We're not able to ping. Yeah, we are able to now. So, I don't know. It's a stupid packet resetting, okay? Nothing wrong with our configuration. You got it, Kavya? You sure?
Yeah. Yeah.
Our network should work, okay? It's a packet tracer fault.
Okay.
So now we have 5 more minutes. We studied how router ID is influencing selecting, taking DR and BDR elections. So let's do modifying using IP OSPF priority, okay? Let's do modify IP OSPF priority. Now you understood the underlying concept here, right? How the elections take place between designated route using designated router, and you also understood how point-to-point and multi-access is different kind of setup.
Yeah.
Right? So all the routers with an OSPF priority of 1 or higher are eligible for election. The priority is set at the interface level. Okay?
Okay.
How I set up IP OSPF priority, you will see now. Okay? Now, what is the interface here? FA01, right? Show IP interface brief. Show run interface FA0 by 1. Right? So FA01 is the interface. Let's go to config T, IP. Okay? Interface. FA0 by 1. IP OSPF priority. You can also, I will talk about authentication key and all at the later step. You need authentication key and everything when you are connecting one area to another area, and both have to synchronize, okay? So at that time you'll give IP authentication message digest, IP OSPF message digest key, MD5, all those kind of authentication, okay? We will discuss about authentication all at the end of the class. So IP OSPF priority, what did I say just? All routers with an OSPF priority of 1 or higher are eligible for election, right?
Yeah.
Then you can ask me 1 or higher. Then what about 0?
Yeah.
If it gives 0, it is out of election. It will no longer participate in OSPF. Okay? You understood, right?
Yeah.
Now you can ask me from 0 to 55. Okay, I selected this as 2. IP OSPF priority 2. Okay? Because 1.2. I just selected randomly. You can select whatever. Okay?
Yeah.
Okay, I will go IP OSPF priority 10. Okay? 20. Okay?
Yeah.
Show IP interface brief. Okay? So show run. So what is the OSPF priority I selected for that interface? 20, right?
Yeah.
Right now, what is designated router? .5.
1.5.
Right?
Yeah.
Backup designated router is .4.
1.4. Yeah.
.2. Now we go here, okay? Enable, okay? Configure T, okay? What I'm trying to do here. Which interface we have to select? Interface? F500, right? Interface, /0/0. What is the IP OSPF?
IP OSPF.
Yeah, it is, right? Here, the 5 is in designated router. We want to test the OSPF priority, right? We gave .2 as 20. I will give .5 as you know what priority I will give? I'll give it as 15, okay?
Okay.
Okay? You agree with me,
Okay.
Kavya? Right, ma'am. Don't forget to save the ma'am. Now, here it is .4 interface, right? So IP interface brief, okay? Configure T. The reason I am configuring everything because OSPF is a very tough concept. You have to configure it in order to understand. Interface, fast Ethernet, 0 by 0, okay? Network, sorry, IP OSPF, priority, you will give it least priority so that .4 will become PR other, okay?
Yeah.
So we want to change the OSPF stage. Okay, now do show IP OSPF neighbor. Which one became designated router now? See, between some time, the election process was retook and which one came as a router ID has been modified. You see that?
Yeah.
1.2 became again DR.
Yeah.
Why? 30 minutes has happened, right? LS advertisements have updated. You see here, we have made router ID, right? Right, Kavya? Remember, Kavya? We reloaded this router.
Yes.
So IP, OSPF database. Now router ID has been changed after we reload. You see, instead of 1.5, 199.231 that become
The next one, because we gave it as 20, right? So now.
no, now not 20, not 20. Earlier, CC. So
Okay.
IP OSPF driver. See, 1.5 become okay. The priority has changed now, but before that, .5 as DR, .4 as BDR, .2 as DR. The reason here 193 has become because show IP interface please. I have added a loopback 0 address with highest IP address.
Yeah.
And the router ID went from 1.2 to 23.1 because 199.1 and 23.1 is bigger than 192. I reloaded the router. That is why router ID has changed from 192.168.1.2 to 199.199.20.1. That is the concept of router ID.
Yeah.
Okay? The first topic that we are discussing. Okay? Router ID. Now we are discussing about IP OSPF priority by changing the OSPF priority. Now see, designated router has become 23.1. Why? Can you someone explain why it has become 23.1?
I mean, because it has the, larger address.
No, actually you are getting confused because meanwhile I have changed the 2.1 address with .2 address with priority higher priority and .5 with middle priority and .4 with lowest priority, right?
Okay.
20, 15 and 10 we gave.
Exactly. So see .4 become the other. Now I will modify this one. After updating priority, what did we update the priority of DR? .5 priority I modified to 15. .4 to 10. .2 to 20. So which one became designated router now? .20. This one become DR other. This one became DDR. You understood how the election took place here?
Yeah.
You understood right how the election took place here?
So Harsha?
I modified priority. Now I gave .5 15, so it became backup designated. .2 I gave 20, it became designated router. .4 I gave 10, so it became designated router other.
So
Now
Harsha,
router ID is not playing any role here.
Okay.
Because IP OSPF priority, we manually assigned it. If you leave the DR election to OSPF, it will choose the router with highest router ID.
Okay.
You understood, right?
Yeah.
Do you want to remove IP OSPF priority and see how the election takes place back again? Are you okay, Kavya? Do you have time? You guys, since Kavya has to drop, you all understand how the election process takes place, right? So in 5 minutes, I'm going to conclude the class, Kavya.
Yeah.
So you also understood the states. I already showed you how the states happen, okay? Full. For example, let's see 1.5 right here. Let us bring down this port, okay? So 5. Let's bring down this link, okay? Now it will go to init. Let us wait. It will either go to init state or it will go to this will down, okay? This will go down. Let me put back. It will go to init state. I want to show you by manually shutting this. Let me shut the network down, okay? Show IP interface, please. Configure the interface. Neighbor down. So here neighbor. Cannot find anything. Let us meet you here. So IP here neighbor. It will wait till that timer expire, okay? That timer is 40 seconds, sir. Let it expire. So what state it will go down? Once you keep the link again upright, it will show init and all those things. Okay, let me do no shut now. I just want to show how the neighbor state changes when it's trying to initiate the link. Okay. Let it expire. So did you understand, Kavya? We also configure these interfaces with different network address, but they are never seen in IP neighbor interface, neighbor ID. Why? Because they are not router IDs. Router IDs are like designated names now. See? It directly went to full, okay? But initially it will show init for a few seconds. And then it will say loading and full. You will see in the real world Cisco devices or any router. And also the advantage of OSPF is if we have some Juniper router and this is a Cisco router and this is a Netgear router, they all can participate without any problem because they are all running IEEE protocol. You understood, right, how this works? I'm going to share. This is end of the class. So this setup is, there are so many other things to discuss, but we don't have time, okay? So this is multi-access, okay? Multi-access network. This is what kind of point to point. Okay. This is a very important class, right? Thanks everyone. Any questions regarding OSPF? That's all. So I have discussed how OSPF is configured, and I also discussed how the election process takes place, and also I discussed how interface states, 8 states of adjacency states, OSPF adjacency states. And I also discussed how the router ID is selected. And the only thing that I did not show you is how the static routes are redistributed into the OSPF adjacent LSA table. How the let's say OSPF database. See, I'm not saying EIGRP topology. I'm saying OSPF database. How OSPF database redistributes the static into it by using this command. Okay. Default information are is there. So if you use this command under the route OSPF, if there are any static routes, right, Kavya Kishore, for example, IP route 0.0.0
space 0.0.0.
I will give some static route, okay, 23.23.4.5, 10. Configure T, right? 23.4.5. Sorry, Kavya, to keep you on hold. I'm almost done. 0 interface. 0 by 0. Let's hope. Okay. Inconsistent address mask. Why? Why it is inconsistent address mask?
I think the IP addresses are in the same subnet somewhere.
Oh, maybe. Not really. This is not the proper static route command, maybe. Destination prefix. It is 0.0.3 like that. I already forgot. You can drop Kavya if you want. I'm just trying to find, okay.
Yes, we have class tomorrow, right, Harsha?
We will have mostly. I will let you know if we don't have. So, show IP OSPF database. Let's see if it is added to here. Not added, right? It added.
I'll disconnect from my phone, but I'll be watching, Harsha.
See, it should ideally connect because there is no such routes exist, right? That is the reason it did not redistribute. Tomorrow I will configure some loopback 0 address that is routed, configured on interface, and then do static route, and then I will show you how default originate command works. Okay? There is also one more important command, passive interface and no passive. Okay.
Okay. So Harsha, this concept of ABR and ASBR will be covering, right?
Okay. See, area border routers and autonomous system border router. That is between.
Yeah.
I configure more areas on a WAN, and then I configure an area, backbone area, and then a stub area, and then a standard area, and then total stub area. To configure all those, I will configure one area, and each area border router will connect to the next area border router. For example, ABR, area backup router, okay?
Yeah.
Area border router, I'm sorry.
Yeah.
So what is the area border router? You have one area, and you have a designated router, okay? So this designated router, if it is trying to redistribute routes to the next area, then what will become? It will become a border router for this area as well as next area. And also, both areas are making selected as one designated router. What will it will be? It will be autonomous system border router, right? Between two areas. Area 1, for example, and area 2.
Yeah.
So it all depends on how you configure it. It's how you design it. I already explained you the different designs. If you can understand between point-to-point topology and this area, and if you connect 2-3 more areas here and define in different area, and what will this area will become? It will become area border router.
Area border. Harsha, we can also.
If you define, I will show you. I will show you the command. Okay. For example, you went on and connected this router to. Okay, I cannot connect any more connections, right? Let me draw it. Okay. Let me take the print screen. Where is print? Okay, I took print screen. Okay, I'm going to paint now. So here it is. Okay. So what I'm trying to say is, now I connected this to one more router. Okay. Okay.
Yeah.
This is connected to one more router. Okay. This
Yeah.
is connected to one more router. Okay. Let
Yeah.
us call this area as area 0. Okay. Let us
Yeah.
call this area as area 1. Okay. So this
Okay.
is border router for this area, and this is border router for area 0.
Yeah.
Right?
Yeah.
Okay. Let us consider this doesn't exist. Okay.
Yeah.
Okay. For example,
Yeah.
we have another area here. Okay.
Yeah.
Multi-access area. Okay. So
Yeah.
if this border router is border for this area, this is area 0, and this is area 1. So this router
Yeah.
is common to both areas. What will this become?
Autonomous border. ASBR.
Right?
Yeah.
And how you configure ASBR, I will show you now. So this is the router, right? So configure T. Okay?
Yeah.
So what is that? Let us assume there is show IP interface. Okay. We have all interface over, right? I don't have any. Let us assume this loopback as a fast Ethernet interface. Interface, loopback. This is as a fast Ethernet 02. Okay? This loopback,
Yeah.
this fast Ethernet 02, let us assume. Fast Ethernet
Yeah.
02, let us assume, connected in another area also. Okay? This interface is connected to another area. What will you do? You will go to that interface and configure as IP. See, in the interface, OSPF area 2.
No, first we have to go router. IP address.
Sorry. Actually, yeah, you need to give IP address. IP address 193.4.5.6.6. Okay. Now IP OSPF area. It should give the area command here. Ideally, it should give the area command here on the interface.
It will it will give from global mode.
No. See. You are not configuring on the global mode. You are getting confused. Each interface you will configure as a different OSPF area under the area. You understand what I'm saying?
Yeah.
In this router, for each interface, on this interface, and this interface, you will configure a different OSPF protocol.
Okay.
This interface and this interface. Okay. On this interface, you will configure area 1, area 0. And this interface, you will configure area 0. Okay? I will show you. I will show an example. Configuring area on OSPF interface. Control F. Area 2. I want the commands. You see that?
Yeah.
On interface mode, you are able to configure.
Yeah.
Let us go to the interface mode here instead of loopback mode. It says SA 0/1. Okay. IP OSPF area. It's not working here, right? But I was able to explain you. So our routers are packet reserved. So the real WAN router. When I say WAN router, they are WAN router. Okay. So,
yeah.
You see, this is very advanced. You are able to understand how I am configuring, right?
Yeah.
So you mention area ID on that particular interface. Difference between ASPR and ABR you are able to understand. And also you will mention, once you have configured two areas on two interfaces, you have to go back to the router. Okay? You configured on each interface with respect to OSPF protocol. OSPF area. Each interface you configured with respect to OSPF area. Now you have to
Okay.
mention which area is stub, which area is a virtual link, which area is NSS stub.
Okay.
You know what I'm saying? How you do
Yeah.
that? Router, see, you create, okay, router. For example, okay, router OSPF 1, right? Or 5. This is 5, right? Configure the router OSPF 5, right? Right? See, both the router ID is same, okay? Router ID is same. Process areas are different, okay? So here you will mention area, for example, 0 as stub.
Okay.
Okay, it is saying it is a backbone. So this is a backbone router, okay? So what is a backbone again? Can you tell me what is a backbone again? So
Backbone, ASBR will be our backbone network. I mean, the router which connects to both areas will be our ASBR.
See, this guy is this is a backbone network, okay? It is not sharing area with another OSPF area. Once you configure two areas on the two interfaces, then it will become ABR or ASBR. Then only you can configure, mention both are stuff. Until then, it is backbone router for which area? Just for its autonomous area, right?
Yeah.
See, I'm explaining the concepts what I have in the mind. I do not implement all this in my real world. I'll just configure OSPF existing.
Okay.
This is what I know theoretically. And when it comes to practically, the important things that you need to understand is how you are passing router ID and whether you have to put it as no passive or passive.
Okay.
I will show you. For example, we go here, configure the router OSPF 5, right?
Yeah.
Okay. Interface. What is this interface here? FA0, right? Passive interface FA 0 by 0, okay? Before I enter this command, I'm coming back here. 250.250.2. Passive interface N. Okay. So what I mean by passive? This interface will no longer participate in OSPF protocol. Show IP OSPF database. Show IP route. So IP OSPF database. In the database, I will show you. Wait. Which interface did I make passive?
You made the 0 by 1.
No, passive interface faster than 0 by 0. Right?
Yeah.
I made this network no longer should be. See, I made this fast unit. So IP interface brief. I made this passive. This network should no longer participate. I don't know why it's still pinging. This is odd. Okay? Ideally, it should not work. This interface I made it passive. Why it's not taking show run? I will tell you why. It is redistributing or what? I have no clue how it... Hey, tell why it is pinging. I found it. Can you tell me why it's pinging? See, we made this interface passive, okay?
Yeah.
That means whatever in this network will not ping, but not the gateway address. So ping 25.2. You understand what I'm saying? We made the network passive, but the network gateway is defined on the router. You understand? Sorry,
yes.
it's also not ping. 25.2 also is pinging. Oh, sorry. We are pinging from the router 7. It's directly connected. It will ping. Let's ping from here. 25 to 25.2. You see? Still pinging. That's not. Shouldn't happen. It shouldn't be happening. I made it passive. Why it is not still pinging? I have no clue, man. So let's make IP interface brief. OSPF PF5, right? Passive interface SA 0 by 0. Interface down or detached. See that?
Yes.
So let's ping from here. What is the address of that one?
25 to 25.
No, this guy.
This guy 26 to 26 to, yeah.
26.26.26.2. It's not pinging because it's become passive. I don't know why it did not work here. This is again packet trace something, okay? So maybe I did not run the command properly. It might be my mistake. See, I make a passive interface. It is no longer pinging, right? Let me ping the network address. You can see the adjacency change immediately. So whenever there is something change in the network, it will update. Remember how it took so long to router ID to update?
Yeah.
But convergence is really fast. So 26.26.26. Okay. I cannot ping it, right? Let us ping. Let's make it no passive. Let's try to ping the gateway. It's not pinging the gateway. So let's ping. Something else. Okay, there's nothing else to ping. Going to configure the router. OSPF 5. What is that? No passive interface. SA 0 by 0, right? Right then. So now adjacency change should come, right? Ping 27. Sorry, still visible because adjacency change has not happened yet. So still passive. Wait. Control C, configure C, router, OSPF 5, no network, no passive, X 0 by 1, I guess, right? Passing to 0 by 0. Yeah, it's framework. So IP, OSPF like. It came back, right?
Yeah.
Earlier, which interface you brought down? This interface? Okay, we made this interface passive. if I make this interface passive also, it should not propagate the network into OSPF advertisements. Okay, should ping now. It's pinging now. So anyway, that's the end of the class today.
Yeah, okay.
We will discuss the remaining things later. Okay?
Okay,
Thank you.
okay, sure.